Hello, my name is Charlie Wright, and I'm a mechanical engineer here at TSI Incorporated. Thank you for watching Performing a Duct Traverse, just one of many short training videos you'll find at the TSI HVAC and IAQ Institute. This video will focus on performing the standard duct traverse with both a pitot probe and a hot wire probe. Performing a duct traverse is done so that we can get an accurate idea of the average flow rate within a specific section of the ductwork. Often air velocity will not be distributed evenly across a section of the duct, so the preferred method is to take multiple measurements at different points throughout the cross section. Each measurement provides us with an air velocity at that point, and the average of all these velocity measurements will be the basis for our flow rate measurement. For this video, we will be demonstrating on two devices, each with the capability of data logging. Having a data logging option can be very helpful when it comes to performing a duct traverse because multiple measurements will be taken. This unit is an Alnor AXD 620 micromanometer and will be used in conjunction with a pitot probe. And here we have a TSI model 9565 VelociCalc being used with a hot wire probe. Both measurement techniques provide air velocity readings. The pitot probe measures air velocity based on air pressure. The hot wire probe uses a technology called thermoanemometry. Both offer extremely accurate results, but the hot wire probe tends to be better at low flow rates. There are a couple of important considerations when we do a duct traverse. It's considered best practice to find a location that's 7.5 diameters downstream of any duct or flow obstruction and 3 diameters upstream of any flow disturbance. Secondly, as we mentioned before, the flow within a duct is not necessarily uniform or even across the duct. Usually it slows down near the duct wall. So it's important to use a technique that will account for that slower flow near the walls. That technique for a rectangular duct is called the log-Chebyshev or log-T approach. For a rectangular duct, the log-T method prescribes on a duct of this size 5 measurements across the duct at 5 locations at each point within the duct. Before climbing the ladder or before doing my traverse, I would have, of course, drilled holes in my ductwork at the proper locations. My probe on the 9565 thermal anemometer is conveniently marked with inch marks, and I know which locations I'm going to be measuring. So I'm just going to proceed and take a duct traverse now. I'll take the same measurement locations at hole number 2 and then proceed across the ductwork in the same fashion. I now have 25 readings that represent the entire flow pattern within the duct. We can now look at the statistics that are stored within the instrument. Using the AXD 620 and a pitot probe, the technique is the same. I have my duct locations. I have rings on my pitot probe. Help me locate the placement within the duct that I need to make my measurements, and I'll proceed to take my 25 duct traverse measurements. After all the points have been measured across the section of the duct, I can review the statistics to find out what the overall average airflow rate was. I can press the right soft key under the stats indicator I see that the flow is the measurement that I'm looking at. My average is 1226 CFM. My min and max number of samples, time and date stamp, and my duct size is also displayed. It's also recorded and can be downloaded from the instrument. Thank you for taking the time to watch this training video on how to perform a duct traverse. If you have any suggestions for future training videos, please email academy@tsi.com. That's academy@tsi.com.